When everyone is looking elsewhere at the Svartsengi volcanic system in the Reykjanes Peninsula of Iceland, Krýsuvík volcanic system, the next volcanic system, is actually building up a fracture zone. And this fracture zone is gradually becoming able, through the porosity, to collect magma in future. These are the tiny earthquakes at a depth of the 4 to 5 kilometers. That's the depth of the magma chamber, or you can say oceanic crust. That's a change in the strength of the rocks, where it can actually have the potential to create a magma chamber. And each system, one after another, they become active. So Sortsengi was active for a long time now, 10 eruptions, and now we are seeing the next one. Krýsuvík is going to have that. The system practically builds up like that. When you think about why 4 or 5 kilometers, as I mentioned, that's the thickness of the oceanic crust. When the oceanic crust rises to the level of the earth crust, what you see is that depth of the 4 to 5 kilometers, there is a change in the material. The strength of the material changes. So it's potentially, through the earthquakes, can develop porosity and be able to accept magma in the future when it is available through the melt. I have a video about this volcanic system. Please watch that. Krýsuvík volcanic system is sinking. And there is a reason for that. I will try to explain it by geophysical data, which shows what is going on inside the earth. These are the earthquakes in the Iceland, the whole island of Iceland. We are dealing with the Reykjanes Peninsula, where the Krýsuvík volcanic system is located in the middle of this image, the lower part of the center. And you see sometimes a green star there. Here I have put a square there, you can see it. And within that we have the Krýsuvík volcanic system. Earthquakes are happening there, and there are numerous of them. And these are the volcanic systems moving and creating what we call as a plate boundary. The plate boundary is exactly where this concentration of these earthquakes is located. The plate boundary between the Eurasia to the right and the Americas to the left. And we can actually see with further data what's going on inside this area. For example, this is again the interferometry. You can see that in the central part near that lake where the line is here. I mark it again here. You see some noise pattern is not rising or very much sinking, probably more sinking than rising. When we have actually a rise is to the left side of this image in the volcanic system of the Sortsengi. And again, it is the GPS data in 3 axes. What we are seeing in the z-axis, up and down, is that the area is going down. Earthquakes actually are creating voids and porosity in the rocks here. These rocks are getting pulverized, crushed at the depth of anything between 9 to 4 kilometers. You can see the depth of the earthquakes under that area. This is all the fault lines. Mark them here. You can see this is an example of this similar formation of the fault lines. They create a weakness zone that later can be filled with the magma. Fracture zone is actually able to hold liquids in it. In the normal cases, we will have water there. Streams will flow toward the surface from there. They're not very huge holes. They're tiny pores, we should say them. Tiny pores are not huge, but yet they can hold fluids. In the case of water, they can hold water. In the case of if it is a magma present in the vicinity of this, can gradually melt them, incorporate them into magma, and form a larger body of molten rock, which we call magma. And this area, due to this shifting, a movement, creates a rift, or as we call a rift valley. The area sinks. You see the lake there? The lake is created because of this. This is what has created our oceans in many ways. And some of the closures of the ocean, when these movements of the faults actually come together. In the Iceland, we have opening up this. And this opening makes the whole earth rise. It will not create a void. It will not create a caldera. The whole earth mantle rises and top part of it melts, and when it can reach the surface, it explodes. It may reach the surface with the explosion or gently flow. This has happened in the past in the Krýsuvík volcanic system. We have evidence for that. And this flow creates this kind of lava flows as we see, volcanism as we call it. And the evidence for that is all over the place in the Krýsuvík volcanic system. In many places on the earth, we have similar situations where the magma has reached the earth surface. These are not creating voids in the ground. The whole earth is rising, reaching the surface. Unlike a caldera. Caldera is the normal stratovolcano. When each stratovolcano is this kind of layered volcano. When the magma leaves the cone of the volcano, the whole cone collapses. And when it collapses into the void, it creates a crater or caldera, and that's totally different to what we see in the Krýsuvík, where we have actually the earth mantle rising due to the stretch and filling up the gap all the time. In the caldera, when the magma chamber emptied, that's it. A void is created and the whole volcano collapses into it, forming what we call as a caldera.